The cosine function. Let's consider the unit circle given by u squared plus v squared equals 1. Now let x be the standard arc measure in radians from 1, 0 to uv as shown. Let's focus our attention on the first coordinate, u equals cosine x, as x makes one counterclockwise lapse around the circle, i.e. x is greater than or equal to 0 and less than or equal to 2 pi. For what values of x does cosine x equal 0? For what values of x does cosine x equal plus or minus 1? There are two positions on the unit circle where the first coordinate is 0, here and here. Recall that cosine of pi over 2 is 0, and cosine of 3 pi over 2 equals 0. Cosine of 0 equals 1, cosine of pi equals negative 1, and cosine of 2 pi also equals 1. Find values of cosine x for the arcs that measure x, where x is greater than or equal to 0 and less than or equal to pi over 2. So here we have at 0, this line here has a length of 1. Cosine of 0 is 1. Now as we go up, the horizontal lines here get shorter, representing the fact that the cosine value is getting smaller. By the time you get up to pi over 2, there is no horizontal line. Cosine of pi over 2 is 0. If we pick a random line here, pi over 4, which is 45 degrees, has a cosine value of 0.707, which you can see compared to the 1 line, it's 0.7 compared to 1. This is also the square root of 2 over 2. Do you recall what happens when the arc x continues its path around the unit circle? The next slide will help. Alright, so here we've just extended these lines across to the second quadrant. So a cosine value here of 0.5 will be for pi over 3, then goes the other way to negative 0.5 since we're to the left of the y-axis. So this point for 2 pi over 3 has a cosine value of negative 0.5. If you look at this line, this was 1, so the cosine of 0 is 1. And to the left of the x-axis, we go all the way over here, negative 1, so the cosine of pi is negative 1. To see the consequences of symmetry in quadrants 3 and 4, go to the next slide. Okay, so if we drop lines down from these points onto the fourth quadrant down here, onto the unit circle, you'll see that they have the exact same cosine values as up here because we're still to the right of the y-axis, so these are all positive cosine values. So the cosine of pi over 6 is 0.866. The cosine of 11 pi over 6 is also 0.866. Over here, we're going to have the same values as up here in the second quadrant because they're negative. So the cosine of 3 pi over 4 is negative 0.707. The cosine of 5 pi over 4 is also negative 0.707. If you have internet, click on the hyperlink below for a Desmos demonstration of the cosine wave. Since the cosine wave comes from the unit circle, we know that the largest value for cosine x is 1, and its smallest value is negative 1, so we can label the extreme values on the y-axis. The range of the cosine function is from negative 1 to positive 1. The unit circle can be navigated clockwise or counterclockwise for all real numbers. This makes the domain of cosine x all real numbers. The cosine function repeats itself every 2 pi units. The graph below shows more than 2 full cycles of the cosine wave. One cycle is for x belonging to the interval 0 to 2 pi, and the second cycle is for x belonging to the interval 2 pi to 4 pi. The graph below shows more than 2 full cycles of the cosine function. One cycle is for x belonging to the interval negative 2 pi to 0, and the second cycle for x belonging to 0 to 2 pi. Reminder, negative arguments x represent going clockwise around the unit circle rather than counterclockwise.